Hello, welcome to PhyzQuest. So in this video we will discuss some of the numericals about vector calculus which appear in the JEST examination from the year 2016 to the year 2019. So in the year 2016 one question came from vector calculus. So the question was, given the condition del square phi is equal to 0, the solution of the equation del square psi is equal to k gradient of phi dot gradient of phi is given by 4 options are given and we need to choose the correct option. So let's get started with the solution. So here we are given that del square phi is equal to 0. Del square phi is the operator is the Laplacian operator, and from this information we need to find out the solution of del square psi. Now del square psi is, the expression is given as k into gradient of phi dot gradient of phi. So basically we have to find out a solution of psi, the expression of psi in terms of phi. That is what we need to do. So we are given here del square phi is equal to 0. Now this is the Laplacian operator expression. Now del square phi can be written as, this is the divergence of gradient of phi, that is del dot del phi is equal to 0. So now divergence is always acts on a vector quantity, and when divergence of any vector is 0 means that vector involves the constant components of I cap, j cap or k cap direction. Because whenever there is constant components are involved, the differentiation or the divergence operator when acts on it, it will become 0. So that means gradient of phi expression will have constant components. So we can write gradient of phi is equal to a I cap plus b j cap plus c k cap. So a, b, c, these are constant terms. Now we have got the expression of gradient of phi. So if gradient of phi is this, from this we have to find out the expression of phi. So now gradient of phi, the formula is general formula is, this is I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. So this is equal to a I cap plus b j cap plus c k cap. Now we have done, when you now mainly we always to have problem when we have given any scalar function and we have calculated the gradient of that. But here is the reverse case. We are having the gradient of phi and we need to find out the phi from this expression. So how to do that? So for that, what you can do is you can compare the coefficient. Here this is the general formula and this is the actual value we have perceived. So if you compare the coefficients, so what will happen is, when you compare the coefficient of I cap, j cap and k cap, what we have got is, this is del phi by del x equal to a, del phi by del y is equal to b and del phi by del z is equal to c. So from this we can have the components of phi. So that is x, y and z components of phi you can get. So if we integrate this, that is if you integrate del phi in the first expression here, suppose del phi is equal to a del x. So if you integrate both the sides, you will get the one component of phi. Similarly, this is another component. Similarly, this is another component. So if you do that, phi 1 is equal to ax, phi 2 is equal to by, and phi 3 is equal to cz. So this is what we have got. Now the thing is, phi is a scalar. So we have got the components of phi, that is phi 1, phi 2 and phi 3. So phi will be equal to phi 1 plus phi 2 plus phi 3, which is ax plus by plus cz. So this is the expression of phi we have got. Now this is about del square phi we have analyzed. Now the real question is del square psi expression we are given. So del square psi is k gradient of phi dot gradient of phi. So now we will first of all write down what is the actual expression of del square psi. So gradient of phi, here this is the value is already there, that is we have chosen this value as constant components. So if we put this value in this expression, this will become k into a I cap plus b j cap plus c k cap dot the same vector, so which ultimately gives k a square plus b square plus c square. So this is the value of del square psi. The Laplacian of psi value is this. Now the question is, we need to find out the solution of this expression. That is, we have to actually find out the relationship between psi and phi. Now Laplacian operator is a double differential operator. That is, it has del square by del x square, del square by del y square, and del square by del z square components. So del square, this is del square psi. Here the constant terms. So as you can see, a square, b square, c square, a, b, c we have already defined, that's they are constants. So del square psi, if it has constant terms, that means it does not contain any x, y, z term. So this is possible only when psi value must have terms like x square, y square, z square, etc. That's the maximum power x, y, z could have. Below than that is possible, because when you take the double differentiation, any higher order term, that is any lower order term, that is from x, y, z or etc., that will goes to 0 when you take the double differentiation. But when there is constant term is there, that means there are terms related to x square, y square and z square. Only then the double differentiation will give the constant terms. Or in other words, only then the Laplacian term will yield the constant terms. And in the expression of phi, we have got the terms, that is ax, by and cz. That means they are x to the power 1, y to the power 1 and z to the power 1 is there. And from analysis of psi, from this expression we have come to a conclusion that psi could have terms of x to the power 2, y to the power 2, z to the power 2. So from this we can say that a psi should be a function of phi square, because phi has x, y, z term and psi has having x square, y square, z square term. That means there is a square term is involved between psi and phi. Psi is a function of phi square. Now look at the solution. Here if you look at the solution, option A and if you look at the options, here option A and option B both are having function of phi square. So other than that, these two solutions are not, these two options cannot be possible, because when there is ln phi is involved, the differentiation will yield 1 by phi. And in the that will definitely not yield any expression like this when you doubly differentiate it. So C and D options are not possible. Only the possibility is between option A and option B. Now we'll check. First, let's start with option A. So if we check option A, psi is given as k phi square divided by 2. So now del square psi is equal to del square psi by del x square plus del square psi by del y square plus del square psi by del z square. Now here if we put the value of phi here, phi is this expression in all the three differential here. See here the first differentiation will be 2 into this term into anyway, ultimately this will yield actually k by 2 into 2a square plus 2b square plus 2c square. Okay. When we doubly differentiate it here, it will, the respective terms will yield the square of the constant terms, that is a square, 2a square, that is 2b square, and the third 2c square, and already there is k by 2 term. So ultimately this will be equal to k into a square plus b square plus c square. So here this solution is actually matching with whatever we have done the analysis. So that means this is the correct solution, option A. Now let's move ahead with next question. Next question is from JEST 2017, and there is one question for regarding vector calculus. So the question is, what is the equation of the plane which is tangent to the surface x, y, z equal to 4 at the point 1, 2, 2? So 4 options are given and we need to choose the correct option. So let's start with the solution. So here we are given the surface xyz is equal to 4 and we need to find out the equation of the plane which is tangent to the surface at the point 1, 2, 2. So here we have a surface here xyz equal to 4. Now first of all, and we need to define a plane which is tangent to the surface. So to define the equation of any plane, you need two things. One is a point on the plane and the other is the normal vector at that point. These are the two things which are needed to define the equation of a plane. So here we have a surface xy phi equal to xyz equal to 4. So now this is the plane which is tangent to the surface at the point 1, 2, 2. Now this point is belong to both the surface, that is since it is tangent, so this point 1, 2, 2 belongs to both the surface x, y, z equal to 4 and the equation and the plane as well. So next thing, see first thing we have already got, that is a point on the plane 1, 2, 2. Next thing is what we need is that is the normal to the plane at that point only. So now the normal to the plane of any point, the vector which is normal to phi, the surface, will be the gradient of the surface. That means the gradient of the equation defined for the surface. So gradient of phi will give you the normal vector. So gradient of phi is equal to I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z, which upon solving, putting the value x, y, z in place of phi, this will give y z I cap plus x z j cap plus x y k cap. Now here this gradient of phi, which is normal to the surface x, y, z equal to 4, will also be normal to the surface that is tangent plane as well at the point 1, 2, 2. Because the surface is touching this plane is touching the surface at this point. So when we take the gradient of phi at this point, that means it is normal to both this surface xyz equal to 4 and the plane which is tangent to it, both of them. Now here we have got the general expression that is gradient of phi for general function. Now we have to calculate the gradient of phi at the particular point 1, 2, 2, which will be equal to 4 I cap plus 2 j cap plus 2 k cap. So this is the vector gradient of phi, that is normal vector at the point 1, 2, 2. So we have got both the things to define the equation of a plane. We have the point 1, 2, 2 and we have the normal vector gradient of phi at the point 1, 2, 2. Now our purpose is to define the equation of the plane. So here when we need to define the equation of a plane, first of all consider any general point x, y, z on the plane. So if you draw any vector on the plane from the point 1, 2, 2 and the point xyz, if you join a line, that is suppose consider a vector on the plane, so that vector will be see the vector is lying on the surface of the plane and this vector is perpendicular to the surface at the point. That means this vector from xyz to 1, 2, 2, this vector is also perpendicular to this gradient of phi. So if we take the dot product of both the vector, it will come out as 0. So now first of all we'll define this vector. So from xyz to 1, 2, 2, when we define a vector here, so the vector will be on the plane will be x minus 1 I cap plus y minus 2 j cap plus z minus 2 k cap. So this is the vector lying on the plane. Now we have to calculate the equation of the plane. To find out the equation of the plane, we have to take the dot product of this vector that is lying on the plane and the vector that is perpendicular to the plane, this gradient of phi. So, and the dot product will be 0. So by solving this, we will get the expression of x, y and z, and that will provide us the expression of the plane. So let's do that. So x minus 1 I cap plus y minus 2 j cap plus z minus 2 k cap dot 4 I cap plus 2 j cap plus 2 k cap. This is equal to 0. So this will be equal to 4x minus 1 plus 2y minus 2 plus 2z minus 2 is equal to 0 after doing the dot product. Now upon solving this, this will be 4x minus 4 plus 2y minus 4 plus 2z minus 4 equal to 0. So if we take the numbers to one side and the xyz to other side, so this will be 4x plus 2y plus 2z is equal to 12. And if we take 2 common and upon further simplifying this expression gives 2x plus y plus z, which is equal to 6. And this is the equation or the expression of the tangent plane. So if we look at the solution, you can see that option D is matching with our result. So correct answer for this question is option D. So now let's move on to the next question. Next question comes from JEST 2019. So in the year 2018, there is no question about regarding vector calculus. There must be other questions about mathematical physics, but no questions about the this vector calculus part. So in JEST 2019, there are actually 4 questions about regarding vector calculus. So now let's talk about this question. So see, this question is, let R be the position vector of a point on a closed contour C. So we need to find out the value of the line integral r dr. So 4 options are given and we need to choose the correct option. So let's start with the solution. So here r is the position vector of a point in a closed contour C. So we need to find out the line integral r dot dr. Now when we deal with the line integral of any vector field over any closed contour, we can use the Stokes theorem. So according to Stokes theorem, the line integral of any vector is equal to the surface integral of the curl of the vector field over the surface enclosed by the closed contour. So here we are given the integral r dot dr and the mathematically the Stokes theorem definition, this is integration of del cross r dot ds. So we need to find out the value of del cross r. So first let's check that. So del cross r is equal to, by using the determinant definition of curl, this will be equal to I cap j cap k cap del by del x del by del y del by del z, and the components of position vector r is x, y and z. So when we solve this, this will be I cap del z by del y minus del y by del z minus j cap del z by del x minus del x by del z plus k cap del y by del x minus del x by del y. So here all the terms goes to 0. So ultimately the answer is 0. So that means this del cross r is equal to 0, which implies the integration of r dot dr will be equal to 0. So this is a very simple problem. So if you check the option, you can see that option A is the correct answer. Now let's move ahead to the next problem. Next problem, the question is, suppose psi A is a conservative vector, A is a non-conservative vector, and psi is a non-zero scalar everywhere. So which one of the following is true? There are 4 relationships are given based on the vector relationship of A and psi. So out of which we need to choose the correct option. So we are given that psi A is a conservative vector. By definition, a conservative vector is something which can be expressed in terms of gradient of a scalar function. Like for example force. Force is a gradient of potential. So, or simply you can say, for any conservative vector, the curl of the vector is 0. So here we are given psi A is a conservative vector, which implies del cross psi A is equal to 0. Now it is also given that A is a non-conservative vector. That implies del cross A is not equal to 0. And also it is given that psi is a non-zero scalar, which implies psi is not equal to 0. So these are the three information we are given. So now using these three information or relationship, we have to find out of the four given option which of the relationship is true. So we are given del cross psi A is equal to 0. Now if we expand this using the product rule of curl, now see here, I'll mention one thing, that I have prepared a detailed video regarding all the possible vector identities, that is including the rule of addition, product rule, quotient rule, that is of gradient, divergence, curl and Laplacian operator. And apart from that, there are also relationship based upon the position vector related to these operators as well. So I'll put the link in the description, so you'll check the video if you want. So here this del cross psi is equal to 0. Now this is, if you expand this, this will be equal to psi into del cross A plus gradient of psi cross A. This is equal to 0. So that means if we take the second term to other side, this will be equal to psi del cross A is equal to minus gradient of psi cross A. Now minus gradient of psi cross A we can also write as A cross gradient of psi. Now here, if we take the dot product on both the sides, on both the terms, this and this, the left hand side and right hand side, if we take the dot product with A, so what will happen is this will be psi into del cross A dot A is equal to A cross gradient of psi dot A. Now right hand side has the expression of a scalar triple product. So scalar triple product is A cross B dot C. This is the expression of scalar triple product. Now if whenever any vector, there are three vectors, now any of the vector is repeated in these terms, out of the three vectors, suppose we have A cross B dot A. So here A is repeated. So this this is applicable to any of the vector B or C, whatever it is. If any of them is repeated here, so this scalar triple product will goes to 0. Now here this formula, this side, the right hand side is very much similar to the scalar triple product. So here vector A is repeated. So that means this term will go to 0. Now if we look at the right hand side, psi del cross A dot A is equal to 0. Now psi is not equal to 0, which is already given. That implies del cross A dot A is equal to 0. So if you check the option, you can see option A is matching with our result. So the correct option is option A. Now let's move ahead to next problem. Next question is, which one of the following vectors lie along the line of intersection of the two planes x plus cy minus z is equal to 5 and 2x minus 2y plus 4z is equal to 3. Four options are given and we need to choose the correct option. So let's get started. So in this question, we are given two planes which are intersecting one another. Now the equations of the planes are phi 1 x plus cy minus z is equal to 5 and phi 2 is 2x minus 2y plus 4z is equal to 3. These are the two equations of the plane. So let us suppose the planes are intersecting one another like this. So you can see that the green plane and the red plane are intersecting one another. So now it is given that we need to find out a vector which is lie along the line of intersection of the two planes. So this is the line of intersection. So a vector lie on this line of intersection like this. So this is the vector, suppose. So we need to find out this vector. So now any vector which is lying on this line of section, this belongs to both the planes. So this vector is a part of this red plane as well as this green plane as well. So now the thing is, any vector which is perpendicular to these planes. Now I am not saying that is perpendicular to both the planes. Any vector which is perpendicular to, suppose a vector is there which is perpendicular to this red plane. So this will also be perpendicular to this vector. Similarly, there is another vector which is perpendicular to the green plane. So this will also be perpendicular to this this vector as well. So now we need, our purpose is to find out the vectors which are perpendicular to these two planes. So now thing is, the normal or the perpendicular to any surface is equal to the gradient of the surface equation. So if we take the gradient of both the surface, the gradient of the surface will give you the vector perpendicular to the planes. So respective vector perpendicular to the respective planes. So for that, the vector normal to phi 1, that is the first surface, this will be gradient of phi 1, which is equal to I cap del phi 1 by del x plus j cap del phi 1 by del y plus k cap del phi 1 by del z. So this will comes out as in place of phi 1, if you put this expression and solve it, this will be equal to I cap plus 3j cap minus k cap. Similarly, the vector normal to the second surface is gradient of phi 2, which is I cap del phi 2 by del x plus j cap del phi 2 by del y plus k cap del phi 2 by del z, which is equal to 2I cap minus 2j cap plus 4k cap. So we have got the vectors normal to both the planes. So now these are the two normal vectors. One is normal to the first plane, other is normal to the second plane. So now the four options are given at this. So here, how to find out the whichever vector is lying on the line of section is, we have to check for the four options. So whichever vector, see, the answer is that option which vector is normal to both these planes. That means when we choose any option and we take the dot product of that vector with both these vectors, and both the dot product will go to 0. That means that is our required answer, because dot product is 0 means to both the vectors, this the option vector should be normal. So we will check all the options one by one. So if we do that, if we take the dot product of each of the option with these two vectors, for the first option, this will comes out as, for first vector it is -1, for second vector is 44, which is not possible. For second option it is, for first vector it is 0, and for second vector it is 0, which is indicating actually it is normal to both the vectors. Similarly for third, option C, that it is, for first vector it is 11 and for second vector it is 36. Similarly for option D, when dot product with the first vector it comes out as 9 and dot product with second vector it comes out at 4. So that means out of all the four options, out of all these four options, when we take the dot product of the four options with these two vectors, only in case of this option B, the vector given in option B, when taken dot product with the first vector and the second vector, that is the normal to both the surfaces, in both the cases the answer comes out as 0. That means this is the vector which is normal to so this is the vector which is not normal, which is the vector lie along the line of intersection of the both the planes. So the correct answer for this question is option B. Now let's move on to the next question. So this question says, what is the angle in degrees between the surfaces y square plus z square is equal to 2 and y square minus x square equal to 0 at the point 1, -1, 1. So let's get started with the solution. So here we are given two surfaces and the equations are given as y fx yz as a y square plus z square equal to 2, and the second surface, let us suppose gxyz, which is y square minus x square is equal to 0. So these are the equations of the two surfaces. Our question is, we need to find out the angle in degrees between the two surfaces at the point 1, minus 1, 1. So one thing you must remember is when we need to find out the angle between the surfaces, you have to think the problem indirectly. Directly finding the angle is a bit difficult. So now suppose you draw a perpendicular or normal to the surface, to both the surface. So whatever be the angle between the surfaces, the angle between their normal will also be the same. Therefore, the angle between the surfaces is equal to the angle between the normal to the surfaces. Now how to find out the normal to the any surface is the gradient of that surface equation. So here I must tell you one thing. See, I have prepared another video regarding the gradient divergence, curl, Laplacian, all the differential operators and their physical significance, the definition, and with practical examples. So I'll link that video as well, so you can check the video if you want. So here the gradient of the surface equation we need to find out. So the gradient of the surface equation, if we apply the gradient on both the surface equation, this will give the normal vector to these surfaces, and we need to find out the angle between those normal vectors. So the angle between those normal vector will give you the angle between these two surfaces. So let's do that. So the normal vector to the first surface, that is gradient of f, this will be equal to I cap del f by del x plus j cap del f by del y plus k cap del f by del z, which comes out as 2y j cap plus 2z k cap. Similarly, for second surface is I cap del g by del x plus j cap del g by del y plus k cap del g by del z, which comes out as minus 2x I cap plus 2y j cap. Now, our question is, we need to find out the angle at the point 1, minus 1, 1. So we have to find out the normal vectors at those points only. So at 1, 1, minus 1, 1, gradient of f is equal to minus 2 j cap plus 2 k cap. Similarly, for second surface at 1, minus 1, 1, the gradient will be minus 2 I cap minus 2 k cap. So these are the two normal vectors we have got. Now, as I said, the angle between the surfaces is same as the angle between the normal to the surface, normal vectors to the surface. So now how to find out the angle between any two vectors? So this is very simple. If you take the dot product of two vectors, let us suppose a dot b. So the definition is magnitude of a, magnitude of b into cos theta. Theta is the angle between the two vectors. So from this formula we can write the angle theta is equal to cos inverse a dot b divided by magnitude of a into magnitude of b. So we will apply the same formula in this case. So we have the two normal vectors to the two surfaces at 1, minus 1, 1 r. Gradient of f is equal to minus 2 j cap plus 2 k cap, and gradient of g is equal to minus 2 I cap minus 2 k cap. So we have the two vectors and we need to find out the angle. So you have to use this formula. So this will be the angle between the two normal vectors are this is equal to theta is equal to cos inverse gradient of f dot gradient of g divided by magnitude of gradient of f into gradient of g. So let's put the values here. So this will be equal to cos inverse 2j cap minus 2j cap plus 2k cap dot minus 2i cap minus 2k cap whole divided by this is the magnitude of gradient of f, that is square root of 2 square plus 2 square. This is 2 square, this is 2 square. For second vector, this is also square root of 2 square plus 2 square. So now this dot product will give you for of both the vectors, only k cap can only give the value, that is ultimately the dot product of both the vectors will give you the value this 4 for the numerator, and for denominator this is square root of 8 and this is also square root of 8. So that means denominator will be square root of 8 into square root of 8, that is 8. So this is cos inverse 4 by 8, which is equal to cos inverse 1 by 2, which is equal to 60 degree. So this is the angle between the two surfaces at 1, -1, 1. So this is all about the problems of vector calculus for JEST examination from the year 2016 to 2019.